Morning everybody and welcome to Papa Lim Physics Classroom. Okay, today we'll be looking at Fleming left hand rule. Okay, we'll look at the device that can actually simulate Fleming left hand rule in action. Okay, now let's take a look. Alright, what we have here is a set of batteries, okay, connected to what we call a board here. On this board here, you'll see this setup. Okay, the red color one that you're looking at here is a magnet, which is a north pole, and the blue color one is actually the south pole. Okay, then after that, on top of the board here, you will see actually a copper rods. Okay, what we are going to do later on is we are later going to switch on the circuit, and you'll find that the current will flow from the positive terminal. Okay, it will go into the positive terminal of the boards, and the current will actually go through the metal wire. Current will go up the copper cable here, okay, the copper wire here. After that, down and back to the neutral side of the battery here. So this is what we call means as a complete cycle. Okay, what we need to take note is that at this instance, when I switch on the circuit, current will actually enter, okay, from the positive terminal, and the current will go up. At this instance, you'll find that the magnetic field line, okay, is actually going downwards from the north to the south. So what we have here is actually the current through the copper wire, copper rods, which is actually going upwards. Okay, so the current is actually going upwards on the copper rod, and the magnetic field line on the copper rod is actually going down. Okay, and at this particular instant, you will find that the current and the magnetic field line is actually perpendicular to each other. So when I switch on the current, and at this particular instance whereby the current and the magnetic field lines are perpendicular, according to Fleming left hand rule, what we will see is actually a force induced on the copper cable here. Before we switch on the circuit, okay, let's try to deduce the possible direction of the induced force. Okay, the current is going up the copper wire. The magnetic field line is actually from top to bottom. Okay, so if you use a Fleming left hand rule, you will find that the induced force will actually be pointing to the left hand side. So it will actually push the copper rods to the left. Now let us take a look to see whether our prediction is correct. Let's switch on the circuit and see what happens, and observe what happens to the copper rod. See, the copper rod push to the left.
Nice.
Now I wonder what happened if I switch the polarity of the magnet like this. Now the polarity of the magnet, you will have actually the south pole is on top, the north pole is below. Okay, the copper rod is still here, the batteries is still at the same polarity. Now, for these arrangements, okay, let's predict, okay, what will happen to the copper rod here. What is the direction of the force induced on this particular situation?